Go.
As all of you may know, my name is Jeremy Eckenrode, and my presentation is on flow distribution. All right, quick overview. I'm going to discuss the background and theory as well as the data we acquired from the experiment, along with some safety, brief safety, and the results and conclusion. Okay, some background. We studied the longitudinal diffusivities of varying concentrations through a packed bed of glass beads. Now, first we did salt water through a packed bed filled with pure or tap water, and then the tap water through a packed bed filled with the salt water in the next week. And the diffusivities vary from 0, which would be the plug flow reactor, to infinity, which would be the continuously stirred reactor, the CSTR. Okay, continued. The axial dispersion model was used, and basically it's used to describe the behavior of the tubular reactors. It also characterizes the mass transport in the axial direction. It assumes the relationship between a longitudinal velocity, which is superimposed on the plug flow velocity. It also assumes that the linear velocity is constant and the concentration is constant as well across the tube diameter. And this accounts for both the molecular diffusion processes and the turbulent eddies and vortices. The equation used is up there, pretty straightforward. Okay, I decided to only use the conductivity versus time for the 4 probes on one slide, as opposed to having many different slides. Hopefully it's easier to read. This is week 1, which was the salt water through the packed bed filled with the tap water. And basically the figure indicates that as I said, the raw data for week 1, whereas a lower concentration of around 7,000 microsiemens per centimeter were used. Now this is the conductivity versus time for a higher concentration, which was around 17,000 microsiemens per centimeter. Okay, so this shows the various probes and the longitudinal diffusivities from each week. And that's pretty much that slide. Now I'm going to discuss the safety, which there really wasn't any inherent dangers in the experiment, but if other chemicals were used, gloves should be worn, of course, as well as goggles at all times, just in case the chemicals used are possibly corrosive or harmful to the eyes or skin. Now the results. When comparing the diffusion coefficients for the salt water into the pure water, it actually decreased, except in probe 2. And then the denser material diffuses much lower than the less dense material. And the week 2 experiment was more of a plug flow than a CSTR, but there was still plug flow, but it was more plug flow in the week 2, and there was some I don't know the word to use. But basically, there was still some inherent plug flow in there. Now, when comparing the pure water and the salt water, the plain water or the tap water flushed out the salt, and it was kind of split between the diffusion coefficient, so we couldn't really draw any conclusions from that based on that. And that's pretty much all I have. So are there any questions? Oh no, I'm sorry. I did have one more slide. I apologize. In conclusion, the saltwater diffusing up through, like I said, through the pure water was a PFR. The pure water flowing up through the salt water was more of a CSDR, but still largely plug flow. And the possible reasons we determined could cause the discrepancies in the experiment was density as a driving force, and also residual ions still stuck on the glass beads in the packed bed itself. And that is all.